Hi! Today, we will learn about the triangle midsegment theorem or the midline theorem. First, let us recall the types of triangles according to side and angles. So the types of triangles according to sides are equilateral triangle, which has 3 equal sides, isosceles triangle, which has 2 equal sides, and scalene triangle, which has no equal sides. Now, the types of triangles according to angles are acute triangle, which has 3 angles that are less than 90 degrees, right triangle, which has 1 angle which is equal to 90 degrees, and obtuse triangle, which has 1 angle which is greater than 90 degrees. So what is triangle midsegment theorem or midline theorem? The triangle midsegment theorem or midline theorem states that if a segment joins the midpoints of two sides of a triangle, then the segment is parallel to the third side and is half as long. Say for example, we have triangle ABC. Now in triangle ABC, D is the midpoint of CA and E is the midpoint of CB. Now joining the two midpoints, we have segment DE. DE is parallel to the third side, which is side AB. DE is parallel to AB, and that the length of DE is half the length of the third side, or half the length of side AB. Using midsegments of a triangle. In triangle XYZ, which segment is parallel to XY? In the given figure, XY is parallel to segment TU. Next, find YZ and XY. YZ is equal to 8 since segment ST is equal to 4. Next, XY is equal to 10 since UT is equal to 5. Next, identifying parallel segments. What are the 3 pairs of parallel segments in triangle DEF? As you can see in the figure, we have triangle DEF, wherein R, S, and T are midpoints of each side. RS is parallel to side DF. ST is parallel to side ED. And TR is parallel to side FE. Example number 2. In the diagram, ST and TU are midsegments of triangle PQR. Now find PR and TU. PR is equal to 16 feet because it is twice as long as segment ST. Next, TU is equal to 5 feet since TU is half as long as side QP. Example number 3. In the diagram, XZ and ZY are midsegments of triangle LMN. Now find MN and ZY. So we have here triangle LMN. XZ and ZY are midsegments. So what is the length of MN? MN is equal to 53 centimeters since XZ is equal to 26.5 centimeters. So we simply multiply 26.5 by 2. Next, what is the length of ZY? ZY is equal to 14 centimeters since ZY is half as long as side ML. So half of 28 centimeters is 14 centimeters. Example number 4. Finding lengths. In triangle QRS, T, U, and B are midpoints. Now what are the lengths of TU, UB, and QR? TU is half the length of SR. So 1/2 of the length of SR, which is 40, is equal to 20. Therefore, the length of TU is 20. Next, UB is equal to 1/2 of the length of QS. QS is equal to 50. So 1/2 of 50 is 25. Therefore, UB is equal to 25. Next, TB. TB is equal to 1/2 of QR. So we are asked to find the length of QR. Given that the length of TB is 30. So if we substitute, TB is equal to 1/2 of QR. TB is 30. So we have 30 is equal to 1/2 of QR. By cross multiplication, we're going to have QR is equal to 30 times 2, and that is equal to 60. Therefore, QR, or the length of QR, is 60. Example number 5. In the given figure, find JK and AB. As you can see, we have triangle ABC, wherein J, K, and L are midpoints. JK is equal to 5, since side AC is equal to 10. Next, AB is equal to 12, since segment KL is equal to 6. Example number 6. In the diagram, ED and DF are mid-segments of triangle ABC. Now find the value of X and DF. So in the given figure, we can say that the length of DF is equal to 1/2 the length of side AB. Now, if DF is equal to 3x minus 4, so we have 3x minus 4 is equal to 1/2 of the length of AB, which is 52. 3x minus 4 is equal to 1/2 of 52 is 26. Now, solving for x, we're going to have 3x is equal to 26 plus 4. 3x is equal to 30. Divide both sides by 3. Therefore, x is equal to 10. Now we can solve for the length of DF by substituting 10 to x. So we have 3 times 10 minus 4. 3 times 10 is 30 minus 4, that is equal to 26. Therefore, the length of segment DF is 26. As you can see, it is half the length of side AB. Next example, given DE is equal to x plus 2 and BC is equal to 18. Find the value of x and DE. So if you can see in the figure, we have triangle ABC, wherein D is the midpoint of side AB and E is the midpoint of side AC. So having the segment DE, which is equal to x plus 2, we know that DE is half the length of side BC. So if DE is equal to x plus 2, so we have x plus 2 is equal to 1/2 of BC, and BC is equal to 18. X plus 2 is equal to 1/2 of 18, and half of 18 is 9. Solving for x, we have x is equal to 9 minus 2. Therefore, x is equal to 7. To solve for DE, we simply substitute 7 to x. So DE is equal to 7 plus 2. Therefore, the length of DE is equal to 9. As you can see, DE is half the length of BC. Next, RS, ST, and RT are mid-segments in triangle XYZ. Find the perimeter of triangle XYZ. Okay, so in order for us to find the perimeter of triangle XYZ in the given figure, we must first identify or determine the lengths of each side of triangle XYZ, given the length of the mid-segments. So, XY, the length of XY is 14 since mid-segment or segment ST is equal to 7. The length of side XZ is 10 and the length of side YZ is 12. In order to get the perimeter of triangle XYZ, we simply add all the sides. So we have perimeter is equal to 12 plus 10 plus 14. Therefore, the perimeter of triangle XYZ is 36. Another example, given X, Y, and Z are the midpoints of AB, BC, and AC respectively. Now, AX is equal to 2. Let me label it in the given figure. XY is equal to 3. And BC is equal to 9. Now find the perimeter of triangle ABC. In order to find the perimeter of triangle ABC, we must first find the lengths of all its sides. So what is the length of side AB? Since X is the midpoint of side AB, we can say that AX is congruent to BX. So if AX is 2, BX is also 2. Therefore, side AB is equal to 4. Now, what is the length of side AC? Since mid-segment XY is equal to 3, we can say that AC is equal to 6. Therefore, the perimeter of triangle ABC is equal to 4 plus 9 plus 6. Therefore, the perimeter is equal to 19. Let's have another one. In triangle XYZ, M, N, and P are the midpoints. The perimeter of triangle MNP is 64. Letter A, find NP, and letter B, find the perimeter of triangle XYZ. So it is given, so the perimeter, okay, let's have letter A, find NP. The perimeter of triangle MNP is already given, which is 64. So in order to find the length of NP, we simply subtract the lengths of MN and MP from 64. So we have 64 minus 22 plus 24. So NP is equal to 64 minus 46. And 64 minus 46 is equal to 18. So the length of NP is 18. Now for letter B, we are asked to find the perimeter of triangle XYZ. In order to do that, we must first determine the lengths of each side of triangle XYZ. The length of XY is 18 times 2, 36. The length of XY is twice the length of segment NP. Next, length of side XZ. XZ is twice the length of segment 22 or segment MN, which is 22. Therefore, XZ is 44. Next, the length of YZ is twice the length of segment MP, which is 24. And twice of 24 is 48. Now, the perimeter of triangle XYZ is equal to 36 plus 44 plus 48. Therefore, the perimeter is 128. So again, always remember that according to the triangle midsegment theorem, if a segment joins the midpoints of two sides of a triangle, then the segment is parallel to the third side and is half as long. Thank you very much for listening.